A star was there, burning, stable, completely normal. Then one day, it vanished. No explosion, no fading, no warning, just gone. In 1952, astronomers recorded a small star, far away, inside a distant galaxy. Nothing unusual about it, not bright, not unstable, just another quiet point of light, one among billions. They logged it, stored the data, and moved on. Years passed, then decades. Later, scientists began comparing old sky surveys with modern ones. They wanted to track how the universe changes over time. Stars move, galaxies shift, explosions appear, some stars fade. But during one comparison, something didn't make sense. The coordinates were correct. The galaxy was still there. Nearby stars were still shining. But one star was missing. Not dim, not hidden, missing. And that's when the mystery began. At first, astronomers assumed a mistake. Old sky surveys were not perfect. Back then, telescopes didn't use digital cameras. They used photographic plates, large sheets of glass, covered with light-sensitive chemicals. When starlight hit the plate, tiny marks appeared. Each mark represented a star. It was a powerful system, but it had problems. Dust could settle on the plate, scratches could appear, chemical reactions could create strange spots. Sometimes those spots looked like stars. So scientists considered a simple explanation. Maybe the star was never real. Maybe it was just a flaw, a tiny mark mistaken for starlight. To test this idea, astronomers returned to the original plates. They removed them from storage, carefully scanned them, digitized every detail. Computers analyzed the brightness, measured the shape, compared nearby stars. The results were clear. The signal behaved like a real star. The brightness matched, the focus matched, the position remained stable across multiple images. This wasn't dust. This wasn't a scratch. The star had existed. So astronomers checked modern observations. They aimed powerful telescopes at the same region of space. These telescopes were far more advanced. They could detect extremely faint light. They could observe many wavelengths: visible light, infrared, radio waves, X-rays. The same patch of sky was scanned again. Visible light, nothing. Infrared, nothing. Radio signals, nothing. X-rays, no burst of energy, no expanding debris, no glowing remnant, just darkness. That's when the problem became serious. Because stars don't simply disappear. Stars live long lives, millions of years, sometimes billions. They burn hydrogen deep inside their cores. Fusion releases enormous energy. That energy pushes outward. Gravity pulls inward. The balance keeps the star alive. But eventually, the fuel begins to run out. And when a star dies, the universe usually notices. Massive stars explode. These explosions are called supernovae. For a short time, a single star can outshine an entire galaxy. The explosion throws huge clouds of gas into space. Those clouds glow for thousands of years. Even smaller stars leave evidence behind. When stars like our sun die, they shed their outer layers. What remains is a white dwarf, a dense stellar core. Other stars collapse further. They become neutron stars. Objects so dense, a teaspoon of their material would weigh billions of tons. Sometimes the collapse goes even further. Gravity becomes overwhelming. A black hole forms. But even black holes rarely stay quiet. Matter spirals toward them. Gas heats up. Energy bursts into space. Astronomers can detect that energy. Something always remains. Some trace. Some signal. But not this time. No explosion. No gas cloud. No glowing remnant. No radiation. Just empty space. Astronomers searched for other explanations. Maybe something blocked the star. Space contains huge clouds of dust. These clouds float between stars. Sometimes they block light. If a dense cloud drifted between Earth and the star, it could hide it. But dust does not behave like a curtain. Dust dims light slowly, not instantly. It also changes color. Blue light fades first. Red light remains longer. Astronomers can measure this effect easily. But the missing star showed none of these signs. Its light did not fade. Its color did not change. It appeared normally in older images. Then it was gone in newer ones, like someone flipped a switch. Years passed. The mystery remained unsolved. Not dramatic enough for headlines, but strange enough to remember. Then technology improved. New sky surveys began scanning the entire sky. Huge telescopes worked every night. They photographed billions of stars. Computers compared every image with older ones. searching for change. Explosions, moving objects, new asteroids, variable stars. But sometimes, the software found something else. A star that appeared in old data, but not in new data. These cases were rare, very rare, but they existed, and that changed everything, because one anomaly can be ignored. 2 raises curiosity. More than that suggests a pattern. The universe follows rules. Gravity shapes galaxies. Fusion powers stars. Time slowly changes everything. Stars are stable. They burn for millions of years. A sudden disappearance does not fit those rules. Some scientists proposed a rare idea. A failed supernova. Normally, when a massive star dies, it explodes outward. But in rare cases, the collapse might happen too fast. The star falls inward, straight into a black hole. The explosion never fully forms. From far away, the star could simply fade, maybe even disappear. But even failed supernovae leave clues. Heat bursts, energy flashes, changes in nearby gas, something detectable. This event left nothing, and that silence is what makes it disturbing. There is also another possibility, more speculative. For decades, scientists have discussed theoretical megastructures, enormous structures built around stars, designed to capture their energy. A star produces unimaginable power. If a civilization could harvest that energy, their technology would grow enormously. One idea suggests surrounding a star with massive collectors. If those collectors enclosed the star completely, its light might never escape. From Earth, the star would appear to vanish. No explosion, no debris, just darkness. There is no evidence this has happened, but the idea cannot be completely ruled out. And sometimes, when the universe stays silent, imagination begins to fill the gaps. But the most unsettling part of this mystery is something else. We almost didn't notice it. The universe is enormous. Our galaxy contains hundreds of billions of stars, and beyond our galaxy, there are trillions more. Against that scale, one missing star is almost nothing, just one lost spark in an ocean of light. If astronomers had not compared decades of data, this disappearance might never have been discovered. And that raises a deeper question. How many changes happen in the universe without us noticing? How many stars disappear quietly? How many cosmic events unfold in silence? The night sky feels permanent, ancient, unchanging. But that feeling is an illusion. Stars are constantly forming, others are dying. Galaxies collide slowly over billions of years. Black holes consume matter. The universe is always changing. Most changes happen slowly, too slowly for humans to notice. But sometimes, something happens faster, something subtle, something silent, and the only clue left behind is absence, a place where light once existed, and now does not.